Okay, hold on. All right. Sine squared theta plus. We agree with that. That's okay. And then what should I do? Someone tell me what I should do next. Okay, hold on. One of you. I'm getting this on the record just so like future generations will know why I've gone insane. Okay. So tell me what I should do. Give me the simple step. What should I do next? So cosine. You want to isolate cosine or sine? Okay, I'm going to do this. That's nice. What can I do now?
Equals to cosine 2 theta.
Ah, so what did you say? Say that again.
Cosine theta squared.
Cosine theta squared is equal to what?
Minus sine theta squared equals to
This?
cosine 2 theta.
Cosine 2 theta? How do you know that?
Double angle.
Ah, so let's rewind a little bit further. I want to go back to the base here. So you have this from something. What do you have this from?
Cosine theta times cosine.
The double angle. What I'm asking you for is, can you remember what the summation of
Yes, cosine theta.
cosine alpha plus beta is equal to what?
Cosine theta
Cosine alpha
cosine theta minus sine alpha times
sine beta, like this. So if instead, if you have alpha equals beta equals theta, you just call it theta. You turn it into cosine 2 theta. So you end up with cosine of 2 theta is equal to cosine theta minus sine theta sine theta. We're just going back to the beginning here. So have we proven this now? So what can we now do with this? What can we do with this? We can substitute it in there. Does that seem doable? So what do we end up with? What do we end up with? So what do we end up with? Cosine of 2 theta plus sine squared theta is equal to 1 minus sine squared theta. Is that true? Now what do I do? What should I move? To the left or to the right? To the left. Okay, so you have 2 sine squared theta is equal to 1 minus cosine 2 theta. So sine squared theta is equal to 1 minus cosine 2 theta all over 2. Exactly. So this proves one of them. Can you briefly explain what you do to prove the other one? You do the...
Well, you can either substitute right from there.
Yeah, you can just change the substitution. You just do a different substitution. So on this one, we substituted for cosine squared. You can make a similar substitution for sine squared, and you end up with the other identity.
Yeah, but I think
you can estimate where the center of mass is going to be, which makes it so that when you find an answer, you can compare it and see if it's remotely correct. So for example, could you make an estimate here? Yeah, you can know if this is half. Is it going to be the x bar? Is it going to be greater than or less than 3 over 2? It's going to be less than 3 over 2, right? And if this is 1 and this is a half right here, that's 1 and that's a half. What about y bar? Where do you think it's going to be? It's going to be less than or more than a half? It's going to be less than a half. We know that's true, so that gives us a nice estimate right there. Okay, so what is this going to be? 1 over ln2, integral from what to what? Of x times what? So e. Why am I doing e here? I don't know. X to the negative 1 dx. Does this simplify nicely? 1 over ln2, the integral from 1 to 2 of what? Of 1 dx. So what's that going to be? 1 over ln2. Is that mighty convenient? Just say yes. It's an amalgamation of convenience. Oh, come on. It's funny. Wouldn't what? Oh, so what's y bar equal to, Alan?
1 over a.
Yep.
From a to b.
Mm-hmm.
X, no. 1/2 fx squared.
Yep. D what? Isn't it still dx, right? We're writing everything in terms of x. That's our stumbling block yesterday. So what do we have? 1 over ln2, integral from 1 to 2. We can pull that 2 out, right? And make it what? What is it now? X to the what? Negative 2 dx. Negative 2. That's fine. Is that okay? I think it's okay. So what do we have here? 2 ln2. What's the integral come out to be, Deanna? No, look at the board and just tell me. Come on.
It comes out to be the final thing.
No, just what's the integral of x to the negative 2?
Oh, x to. That's what I said.
Wow, we're really confusing Deanna here, and I'm going to put this on pause. What does that come out to be? If you evaluate this. It's going to be negative a half minus negative 1. So it comes out to be 1 over 2 ln 2 times what? 1/2. Nice. So it's 1 over 4 ln 2. Nice. 2 on this one.
0.
Why?
Because symmetric to the y-axis.
Because it's an even function. Yeah, it's even. Which means it's symmetric across the y-axis. Correct. Very nice. So these functions right here are exactly the same as what you've just done, except what are we introducing right here? Changing density. Yes. That's the only thing. Draw me the picture of what this is describing and write the integrals. That's all I'd like you to do. We're not going to evaluate it. I just want you to write them down for now to start. About this one, it says the density at any point on a semicircular lamina is proportional to the distance from the center of the circle. Find the center of mass of the lamina. So this is what I would like to ask you to do on this one. We're going to break this into pieces here. Can you write me an expression, just an expression, don't evaluate it, for the mass of the lamina?